Small surface defects are difficult to detect with conventional inspection tools like the surface comparison. Surface defects have a low scale and are normally smaller than the tolerances of the CAD. Therefore, irregularities cannot be visualized in the color plot of a surface comparison. In GOM Software 2016, you can use the new function Surface Defect Map to determine and visualize small bulges or depressions. The function computes a theoretical surface based on a mesh for more realistic results. The surface defect map can be directly created on an actual mesh. It is also possible to use the function on nominal data. In addition, the software allows the comparison between the nominal and the actual surface defect map. Let's have a look how you can use the function on actual data. To demonstrate the new function, I use an actual mesh of an injection molded part. There are stiffeners on the inner side. I want to analyze the influence of the stiffeners on the opposite surface side. For convenience, I create a local coordinate system first. It's useful for setting the direction parameters in the surface defect map dialog easily. I construct a local coordinate system by 3, 2, 1 to get adequate directions on the object. Now I construct the surface defect map. The parameter maximum defect size is related to the maximum size of a defect. Choose the direction in which the software should create parallel inspection sections. In this case, it is the x-axis of the local coordinate system. The normal direction should be perpendicular to the selected surface. Select the area on the surface which you would like to inspect. To get more information about parameters, you can use the direct help. You can already see the defects caused by the stiffeners. The surface defect map is displayed in the Explorer within the category Dimensions. For further inspection, you can use the function Surface Defect Comparison against Nominal. The function allows the setting of filters and tolerances. Using the filter function, you can filter the computed inspection values. If you choose an average filter, the software smooths the computed values. With this value, you define a search radius. You can view the effect directly in the preview. In addition, you can transfer values from the surface defect comparison to a section or curve. The values can be displayed in the diagram. To find out more about how to extract values, you can use the direct help or the video tutorial. To display discrete values on the surface defect map, you can add deviation labels as usual. Using iInspect, you can display the maximum and minimum deviation label. In addition, you can add a label with the results overview. You can show the values of a distinct region. Change the legend to the tolerance legend to allow simple OK and not OK decisions. The inspection results can be displayed in a report page. The surface defect map was created as an actual element. You can also create a surface defect map as a nominal element. By comparing the nominal with the actual surface defect map, the new feature allows the compensation of the global curvatures. For more information about this effect, you can read the direct help of Create Surface Defect Comparison on Actual. The color plot of a surface defect comparison is shown on the right side. The comparison visualizes small bulges or depressions. To create the surface defect comparison, the software compares each selected point of the actual surface defect map with the point of the nominal surface defect map. Therefore, the comparison requires an adequate alignment of the specimen on the inspection area. For example, it might be useful to align the desired area on the actual data to nominal data via a local best fit. I'd like to show you how to create a nominal and an actual surface defect map and then the comparison between them. The glove compartment lid has stiffeners on the inner side. I want to analyze the influence of the stiffeners on the opposite side. The surface comparison does not allow to visualize the influence of the stiffeners very well. Therefore, I will create a surface defect map on the nominal glove compartment lid. A local coordinate system without measuring principle already exists. Select the area which you would like to inspect. Based on the selected area, you can construct a surface defect map. I'd like to inspect along the x-axis of the local coordinate system. To create an actual surface defect map in the same way as the created nominal surface defect map, use the measuring principle referenced construction. The software then reproduces the surface defect map on actual data. To compare the actual surface defect map with the nominal surface defect map, use the new function surface defect comparison on actual. You can adapt the other parameters as mentioned previously. To view the defects precisely, adapt the legend. The defects are about 0.15 mm. Due to the new functions, surface defects are visualized precisely.